Hello, today I'll be going over the final part of Section 1 of the Science Resource Guide, Electricity in Materials. The first one is static electricity. The most common static electricity occurs when two different materials are rubbed against each other. Rubbing causes electrons to transfer, where one object becomes positively charged while the other is negative. Scientists do not fully understand why some materials gain or lose electrons more readily, but it's whatever. And then static charge examples. The transfer of electrons can cause static link, as seen right here. This happens when two different material fabrics stick together, such as acrylic and cotton. Fabrics of the same material do not stick, such as cotton and cotton. Another example is when you walk on your rug with socks on a dry day, you build up excess charge. When you put your hand near a metal doorknob, the charges will move through your hand to the metal. This will shock you. A von de Graaff generator helps demonstrate static electricity through a mechanical process. It consists of a vertical conveyor belt that rubs two materials. The belt then transports the electrons to the top of the metal sphere. When we touch a von de Graaff sphere, the electrons will transfer to your body. This will cause your hair to repel each other and stand up, as seen right here. This shows us that electric force is vastly stronger than gravitation. When you rub your hair against a balloon, the balloon gains electrons. The balloon becomes negatively charged while your hair becomes positively charged. The difference in charges pull these two objects together. We call this attraction electrostatic attraction. Now, if the balloon accumulates enough negative charge, it can even stick to a wall, even if the wall has no charge. This is because all atoms, including the walls, contains positive and negative charges. The negative charge from the balloon repels the wall's electrons. The wall's nucleus, which contains both protons and neutrons, is then pulled toward the balloon since opposite charges attract. When this happens, the atom becomes lopsided and is known as being electrically polarized. And you can see right here, the negative charges and the positive charges attract each other and cause it to stick. Some atoms and molecules are naturally polarized due to chemical bonding. Water, also known as H2O is an example. Oxygen's positively charged nucleus attracts the hydrogen electrons. The molecules is more negative on one side and more positive on the other. This creates an electric dipole. Since water is polarized, they are attracted to any object with the net electric charge nearby. Ions are atoms with unequal protons and electrons, so they have a net electric charge. Polarized water molecules neutralize these ions. This is why you do not get a lot of static electricity on humid days. So, that being said, you'll more likely be shocked on dry days. And we can see on the graph right here, as your humidity increases, the rate of static charge decreases. Conductors and insulators. A substance can be a good conductor in two different ways. First is electric. Electric conductors allow electric charge to flow through easily, and the next one is heat. Heat conductors quickly exchange thermal energy with its surroundings. Both types of conduction occur because of the loosely bound outer, also known as valence electrons. In metals, their valence electrons move freely between adjacent atoms. The loose electrons is often called a sea of electrons. Examples of good conductors would be copper and aluminum. Materials like plastic and rubber are insulators. They prevent the movement of electrons. Copper wires are coated in plastic for safety. If a conductor gains a net electric charge, the electric field at all points will be zero. For example, a charged metal sphere, electrons spread across the surface to be equally spaced apart. There will be an equal repulsion in all directions, canceling out the electric field. Now, if the conductor is not spherical, the charges will distribute differently, but will still have a zero electric field. Objects with corners tend to have higher density of charge compared to flat surfaces. An example would be the lightning rod. Then this is the final slide. A Faraday cage. A Faraday cage shields what is ever inside from external electric fields. An example would be a car. A car functions as a Faraday cage during a thunderstorm. The car's metal frame protects passengers from the lightning by keeping the charge on the outside. And another example would be microwave ovens. Um, when you put your phone inside a microwave, it will not work because the metal blocks out external radio waves. And this is the end of this video. Thank you for watching.